Hi. Thank you for coming here. I know this is a magical place for fairies and also Node.js developers. So today I'm going to talk about optimizing life in Node.js. That sounds like too generic, but this was one of those ideas that came out through Twitter. I reached out to a couple of friends, and Nicola from Babel basically told me that, like, you have a kid, you are married, and you're also contributing to Node.js, and how does it even work? And like, here's my kid. So yeah, let's start. Who am I? I'm a principal systems engineer at Cloudflare. I'm a Node.js TSC member. I contribute Node.js, and I have a decent life. I'm a social person. Yeah, yes. Some fun facts. Since January 2021, I'm married with my lovely wife, Merve. As of June 2023, I made a person called Ada, and also named after the URL parser of Node.js. Yay! As of August 2024, I made 263 commits. As of right now, it's 300 commits or something. I'm giving you these facts because it all pans out eventually. Some of my recent contributions: Node Run, mfile, new URL, can parse, and lots of performance improvements. So I'm here to share my secret sauce with you, how I did that and how I optimized eventually, how I became a slave of my engineering experience, and how I optimized my life and eventually started contributing to Node.js. So how did I really optimize my life in Node.js? It's a three-step process. Basically, it's about optimizing marriage. I'm going to dive into that. The second step is optimizing kids. It's not possible. And the third step is optimizing software. Let's start with the marriage. Are you familiar with OR gates? Of course we are. If A is true and B is true, A or B will result in true. If A is false, then well, you know how you're familiar with the OR gates. So let's start with the married logic. This is one of those slides that I took from a really one of my favorite comedians. I forgot his name. Not that much favorite, I guess, but so let's start with that. This is like this is how I optimize my marriage life. We have a situation: Yagiz, Merve, and the result. If Yagiz is wrong and Merve is right, what do you expect the result is? Merve is right. If Yagiz is right and Merve is right, what do you expect the result is? Merve is right. And if Yagiz is right and Merve is wrong, then Merve is right. If we are both wrong, then Yagiz is wrong. So this is basically a small intro to marriage. I've been married for 5 years. I have a beautiful kid, and yeah. But so how about our daily lives? Let's dive into a little bit less stressful topic, which is a kitchen. Right now, as you can see, this is a lovely kitchen. It's extremely clean. We have drawers, we have sugar, we have coffee, we have pots, we have different kind of things, and there's a lot of energy and time has been invested into improving the design and the usability of this kitchen. If you look into a little bit into the situation, you will see that within my hand distance, I can reach out to utensils. Within my hand distance, I can reach out to the bowls, because let's say I'm mostly a bowl guy. I eat cereals and so on and so forth. I consume coffee and sugars, and that's why it's extremely close to my vision, my eyesight. If you look into the details of the drawers, you will see that the depth of the drawers are explicitly not too deep, but also not too shallow. And when you open it, the first thing that you are going to see is how the items that you use mostly. For example, utensils will always stay in the top left shelf or the middle, but the things that you don't access most, let's say knife, are going to be one of those at the back area. This is a way that we eventually optimize ourselves without even knowing how efficient we are as human beings. So Node.js is not very well, not different than Kitchen. We basically do the same exact thing, but with knowing the fact that our goal is to optimize our usability for how to access certain things through certain scenarios. So let's start with text decoders. We all know, we all use text decoder at one time in our lives. It takes an input of uint8 array. You create a text decoder using text decoder UTF-8. It has a function called, instance function called decode, which takes an uint8 array, and it converts that uint8 array, it decodes it into UTF-8 and gives you a hello world. So this is not always true, because text encoder is not as simple as it seems. As a user, we all see that that's the case, and we assume that it is it's extremely easy to optimize and cut corners and find small wins in it, but there are some folks in the community that we call standard makers that doesn't help us because there are too many cases that we wanted to support. So the actual definition of text decoder is that the first parameter is UTF-8, but in the previous example, I omitted the options because it's almost never used. But we have an ignore bomb value, we had a faro value. So encoding, the possible values are UTF-8, UTF-16, lower endian, big endian, and there's tons of other things that ICU supports, but I don't even know them. And I assume we all don't know them unless we are James Snell, which implemented most of those things. Let's look into ignore bomb. True if the byte order mark will be included, false it will be skipped. Unless you explicitly come to this example, you never know what bomb is. We have fatal, true if errors should throw, false it should return a string with a replacement character. Again, we almost never work on these kinds of things, but the API surface that's defined by the text decoder gives us the options to configure them as much as we want them. So what's the cost of supporting all of these options? Wouldn't be life would be easier if we just did a new text decoder? It's like having a single language in the whole world. Why do we have multiple ones? Because there are different cultures, there are different places, we are not all raised in different places, and so on and so forth. So according to the spec, I don't know. We need to make our lives harder. So what do we know? Let's get some facts about text decoder, because that's a great example, I guess. So text decoder uses string decoders. String decoder uses ICU, and ICU is slow and complex, the enemy of performance and me. So let's dive into all of these steps. Text decoder is a class inside Node.util, and it's also a global defined by the web standards. Internally, whenever you create a text decoder, if you're not using UTF-8, then it creates a string decoder instance. String decoder class is available through Node.util, I assume, or it has their own module. And string decoder uses ICU, which is an encoding library that's used by almost all libraries that you know of. Without you knowing, probably you have more than tens of duplicate ICU binaries in your computers right now, because every library, every Electron app, every single application that you define, like that you use, depends on it to have localization support for different languages, for different things, and for different inputs. ICU is slow. This is a kind of a fact, but it's getting better. And yeah. So let's dive into, before diving into how we can make text decoder a lot better, let's remember the kitchen. Previously, I showed you this kitchen to show you how efficient we are if you look into the kitchen from a particular point of view. But in reality, that's not correct. If you dive into with an educated mindset and with an educated eye, if you look into this kitchen, you will see that there are lots of inefficiencies in this kitchen. For example, the ratio to coffee and sugar is extremely different. It's like 2 to 1. Who puts two cups of, like, 2 spoons of sugar and 1 spoon of coffee? no one. If you look into the pot stands like in the middle. The pot stands in the most efficient way, and it stands on the shortest path to my hand, even though it's extremely hard that you will need you will need it, and so on and so forth. So as you know, while implementing those kitchens, just like standards, if you're not looking for performance, if you don't have performance in your #1 priority, it's extremely easy to create a beautiful kitchen which serves all of the purposes, but it actually creates inefficiencies, and it lets you waste too much energy while doing the same operation millions of times. Yes. That's optimized for common people, not for the spec. So this is what I was talking about, which is the common use case. The fatal true, ignore bomb false. These are the default options. So if you, and the text decoder is almost always used by UTF-8. So how can we optimize this? We can just add a fastpath, meaning that we can cut corners into the actual implementation and make certain hot paths fast, so that we can we are not paying the cost of creating ICU, and we are not always paying the cost of those standard compliant functionalities. Meaning that in the constructor of text decoder, you will see that there's a Boolean called with a symbol of UTF-8 fastpath. Is only true if the encoding is UTF-8, and then on the decode path, if the option stream doesn't exist, and if you are a UTF-8 fastpath, then you can explicitly bypass the creation of converter, which is the ICU converter, and directly call decode UTF-8 and make your UTF-8 decoding 80% to 100% faster than the actual ICU-based path. And this is just a small example that if you have a particular approach to solving a problem, you can cut corners, still be spec compliant, but improve a particular hot path in a significant way. So text decoder is not the only place that we can do it. We do it in different languages. It's not specific to JavaScript. It's not specific to C++. It's not specific to Rust or Zig or any other languages. It's done in different places, and it will be done in different places as well. So another example is that buffer.byte length. Previously, I showed you that encoding, we are optimizing for the hot path. We are doing the same exact thing for byte length. Whenever we call buffer.byte length, we are optimizing, we are running byte length UTF-8 on UTF-8 values, and for ASCII, we are returning the default value. We don't even need to call a C++ function there. And for the rest of it, we call ops.byte length, which calls C++. And then we have a different kind of optimization. So in the previous examples, we go straight for cutting corners, because we knew that this was a hot path, and we knew the inputs that will be a lot more used than the other variances. But for the example of swap 16, the buffer length, if the buffer length is less than 128, we can just do it on the JavaScript side and skip the conversion to C++ side. This is a great example because the input types and also the input values are a factor of focusing on how and what we should optimize for. Most of the time, if you call swap 16 with a length of 10, it's extremely slow if we go for C++, but we can do that in JavaScript because V8 optimizes if that for loop is less than 128. And another example, this is an example in C++ to show you that this is not a language-specific problem, but it exists in different areas of project. Meaning that if we have a fast byte length UTF-8 value, for inputs bigger than 128, we call simd UTF function which calls CPU, which executes specific CPU instructions depending on the CPU that you're running your application on. But if the input length is less than 128, then it directly goes for a scalar implementation, which is going to be slower, but slower for inputs bigger than 128, but it's faster compared to the sim version. So the implementation of the function also changes the way that we perceive the length and like our optimization. So I guess it's time to wrap up. Optimize the hell out of your life, just like Node.js. I hope you liked my talk, and thank you.
Amazing. Fantastic. Thank you very much.
Any questions?
Any questions from the audience? All right, let me grab a mic real quick.
So some of the hot paths that you showed there are fairly obvious of why they are hot paths. Like UTF-8 is the most common text encoding, so it makes sense to optimize for that. But how do you find what the most used set of options is for something to kind of know to optimize for that?
So the thing is, it was obvious because of how this presentation was delivered. If you look into the first kitchen photo, I didn't even realize that the coffee to the sugar ratio was that much obvious. So it's kind of an eye-opening experience for me as well to prepare this slide. So for most cases, even for me or even for anybody else, I don't know, but it's not that obvious, and it's mostly a trial and error situation, or even looking at the same exact function for 10 different times, and on the 10th time you realize that, yeah, we can cut the corners for that. So there is no direct path to success that I can say.
Yeah, thank you.
Yeah.
Beautiful. Another question over here.
Hello, great talk.
Hi.
You mentioned that ICU is slow. Do you know if there's, I realize some of these were JavaScript land optimizations, but are there changes that could be upstream to ICU to make it fast for all users? As well?
So I only implemented a subset of ICU in Ada in order to utilize 2ASCII and 2 Unicode implementations. And so the main reason that ICU is extremely slow is that the specification is extremely
because it's like a reference specification, it does everything.
It's too hard to read and too hard to comprehend unless you're an expert, and I don't know, I'm not an expert according to, I couldn't understand it properly, so yeah.
I'm just going to say, it is an open source project. Yes, it is possible, but it's a hell of a lot of work.
Yeah.
Say, yes, it's an open source project. It is possible to contribute these things too, but it's an extremely complex project. So it would take a lot of time. And just finding the paths, I think Yagiz was just saying, would be quite difficult.
Yep.
Complex, just like life. All right.
Yeah.
Do we have time maybe for one last question?
Yes.
Here you are.
Hello.
So you showed a V8 fast API implementation.
Yes,
So
unfortunately.
next year, can you do a workshop on how we do those so we can have more people
Definitely.
contributing
Why not?
that?
Why not? I broke 22.5 with that, so I can share my experiences there. So,
Yeah, I did 22.7, so...
yeah, so we're like brothers. Yeah, definitely. If there's enough interest, I can.